Okay, so now we're going to go over geometric probability problem number 4. We have two CB radio operators, Tiger Lily and Huge Huey, working for Carl's Trucking. The range of their radios is 25 kilometers. So Tiger Lily is traveling toward the base from the east at 3 p.m. and is somewhere within 30 kilometers of the base. And Huge Huey is traveling from the north at 3 p.m. and is somewhere within 40 kilometers of the base. So what's the probability that they can communicate with each other at 3 p.m.? Okay, so I'm going to put Tiger Lily on the x-axis, and I'm going to put Huge Huey on the y. And the furthest that Tiger Lily can go is 30. And the furthest that Huge Huey can go is 40. So we're going to have a rectangle for our sample space because they can each, Tiger Lily, it's okay for Tiger Lily to be 30 and Huge Huey to be 40 at the same time. All right, now in this case, their radios can only be 25 kilometers apart. So we're going to use the distance formula to figure that part out. So square root of x minus our origin, we're putting the base at the origin, so it's going to be x squared, plus Huge Huey would be y squared away, and that distance can only be 25. So if you square both sides, what we really have here is a circle. So they are going to be able to talk to each other if they are each 25 away from the base. And so then the feasible region that we're looking for is this quarter circle, because we're only in the first quadrant on this one. So the probability is 1/4 pi r squared, the radius is 25, divided by the sample space, which is the area of the rectangle, 30 times 40. So that would be 625 pi over 4 divided by 1200, which simplifies down to 25 pi over 192, or approximately 0.409. So that's problem 4. Now, problem 5 says a swimmer starts from the beach in a fog and swims 500 yards in a straight line in a random direction. So here's the beach, here's where they start, and she swims out 500 yards. But it's actually going to make a semicircle because we can be anywhere from this point. All right, now from each one of these points, she can shoot out another 500 yards at the most, because we want to know what's the probability she's going to reach the beach before going another 500 yards. So she doesn't know which way she's going to turn. She might go towards the beach, she might go out. But all these circles centered here are going to end up making another circle here. And this is an additional 500. Okay. So what we have then are two circles, one with radius 500 and the other with radius 1000. Okay, and we want her to swim back into this region right here. So then the area of that first circle is going to be half, our first semicircle is 1/2 pi times 500 squared. And we're going to divide by our sample space, which is going to be 1/2 of pi times 1000 squared. And when you do the arithmetic and reduce, the answer is 1/4.